everyone, welcome back to Manufacturing Hub. If you guys are watching live, this is a Wednesday afternoon. If you guys are listening in podcast form, this may be a Thursday or any other day of the week, because who knows when you're actually going and listening to this, or when we've gone and posted them online. Having said that, if you guys have been here before, welcome. If you haven't been here, or if you've been here before, welcome back. If you haven't been here before, welcome. Every month, myself, Dave, and my co-host Vlad, we have a different theme. This month we're split in half. The last couple of weeks we talked all about AI, which has generally made me rethink a lot of the thoughts that I had about it. And maybe we'll go touch AI with Sean at some point later when it comes to robotics. The second half of this month we're talking all about robotics. We've got a couple of returning guests on. We've got Sean, who we will reintroduce, and he will go tell us a little bit about what he's doing now. And we've got Pavel on next week. So two really fun conversations. We want to go deep dive into some more of the robotics specifics. So if you guys have questions, especially as you're watching live, please feel free to go ahead and drop them in the comments. Tell us where you're at. If you have questions for Sean or Vlad or myself, please feel free to go ahead and drop them in, or go ahead and reply to each other. That is some of the most fun parts of the show. If we have the opportunity, we'll go bring them in and we'll go ask Sean, or we'll go answer those questions. If we don't, we'll do our very best to get to them after the show. But without further ado, everyone, officially welcome to Manufacturing Hub. This is episode 214. We welcome Sean back on. Sean, welcome back to the show. Thank you so much for being here.
Hey, thanks for having me, guys. Appreciate it. It's always a fun time.
Absolutely, Sean. Thank you so much for taking the time. Before we dive into robotics, right? So obviously Dave mentioned you've been on the show a couple of times, but I do believe a reintroduction is definitely in order. Could you tell us a little bit about your background, but ultimately what have you been doing lately?
Sure. Yep. So Sean Dotson, I think most people, know me from having started R&D automation company out of Sarasota, Florida. Grew it up and sold it a few years ago. Just had its 20th anniversary actually this last year, back in January. Took a little time off after I sold it. Did a little bit of advisory work and consulting. But as of February of this year, I was asked to become CEO of Elite Robotics. They're based out of Utah, North Carolina, and soon to be Florida. We specialize in material handling, so large end-of-line material handling robotics projects, as well as automated storage and retrieval cranes. So these big, huge warehouses that have, pallets stacked, 30, 40 rows high and 30, 40 rows deep, large cranes that move back and forth and take pallets out, take totes out. In fact, we're doing a project right now that's taking car bodies and pulling them out and putting body in white, onto a conveyor that then goes and gets the rest of the assembly done. So, it's drinking from a fire hose, learning a new company, putting some new processes in place, and really excited about, spinning them back up. Kind of a little bit of a reboot of the company, but got a really, really good team, and I've been very happy with it.
Let me ask you, Sean, a follow-up on that side, right? So material handling, I would assume I have a pretty good definition in my head of what that is, right? But I'm assuming something like obviously welding or painting would not be part of the wheelhouse. But if you're maybe moving or you're doing machine tending, does that still fall under material handling? Could you give us maybe a perspective of what that means?
Yeah, I mean, material handling, it's a vague term, right? I mean, you're handling materials, right? So, but typically what a lot of people will talk about is it's the simple stuff like palletizing, depalletizing, boxes, bags, things like that. That's stuff we can do and we have done in the past. We've got standard solutions for it, but we are differentiating ourselves a little bit by things that you wouldn't necessarily consider. So you've got machine tending. People usually think of lathes, mills, things like that, small parts loading up, a CNC. But we've done machine tending where it's like taking a door blank, putting it into a router that then adds the hole for the knob and the pockets for the hinges and things like that, or taking sheet metal and putting it into a laser, laser cutting or a water jet. A routing machine, things like that. So, machine tending definitely falls in that category. But even it's just moving things around, like palletizing or depalletizing oddball shapes, like 55-gallon drums or 5-gallon buckets of paint for Home Depot or Lowe's or something like that. So again, I've talked about having niches before, and I think that's kind of one of our good niches is that large scale material handling.
Let me try and expand, I guess, on projects of that nature, right? So obviously there's the robotic side, but there's also, I want to say, auxiliary components, right? So end of arm tooling, I want to say vision systems, there's usually controls, there's safety. So I'm curious, maybe if you could paint us maybe a picture of what a material handling solution looks like, but also,
Sure.
I'm curious, where does the challenge lie, right? Is it different from project to project where it's, let's say, almost always end of arm tooling needs to be figured out and is a huge nightmare when
Right.
it comes to some of these?
Yeah. So it's really not different from my previous life, which was more front of line assembly machinery. That's where I kind of my old company was more in line with that. Small robots, putting things together, inspecting them, and all. This is much larger robots moving much larger things, but a lot of the same components. Yeah, we still use vision systems, barcode scanners, barcode readers, labelers, other inspection sensors and devices to be able to look at something, maybe to measure box size or to measure length of something if we're sorting by length, things like that. So again, it is a lot of those same components. You have to have good relationships with your vendors and all. You talk about challenges. There's always little challenges everywhere, but when you're talking about conveyance of these things, it's a conveyor for the most part, right? I mean, it's not real rocket science. There's always oddball things that you're trying to convey, and maybe you have to have some specialized conveyor for it. But for the most part, a lot of that's kind of standardized. Your safety fencing, your guarding, your push buttons, all that fairly standard. So, I like to say that for what we do for the material handling back end is probably 70% what I'm gonna call standard, right? Maybe it's different lengths and widths and arrangements. It's kind of the same components over and over again. Yeah, the end of arm tool usually is one of the big things. Is what are you handling that day? Are you handling a bucket? Are you handling a door? Or are you handling a case or a bag or something like that? So that's usually the biggest challenge. Although there's other oddball challenges too. Sometimes it is the vision system trying to look at objects. We had a project where we were palletizing cinder blocks, but these are not standard cinder blocks. They're all different sizes and shapes of cinder blocks. So we were using vision to determine what block was coming down, where it was on the conveyor, how we would pick it up. Teaching the robot to pick it up at a different angle because it's skewed coming down the conveyor. So, there's challenges on every project, of course.
That almost sounds like a 3D game of Tetris, right?
Yeah.
Like you're trying to scan the block and see where can you fit the
Yeah.
next block, I guess, that's coming your way.
Exactly.
Dave, any thoughts on the project side?
Yeah, absolutely. I guess I would love to know, Sean, kind of from your perspective, and maybe this is as the new business CEO, maybe this is in a broader sense. Are you picking, one robot and we're trying to do as much of the material handling and projects on one robot? The difference is the end effector and the difference is the software. Are you picking like one group that you're buying the conveyors from, or the specific hardware conveyors, vision systems? Are you planning, is the goal to standardize as many things so it's more of a product as opposed to like as opposed to almost like a research and development project on very customized things every time? What's the philosophy to that?
So our philosophy is to try to standardize as much as possible. Now, we will always have customers who says, I've got 100 miles of XYZ brand conveyor. I really don't want a different brand conveyor. Can you use XYZ brand? And sure, of course, we can do that. We do have a partnership with a company in the UK. They actually do make a lot of conveyor for us, guarding various other objects that they quite honestly, great pricing, and they'll also white label it for us as well. So we've got our Elite branded conveyor. So which is always helps build your brand, of course. The secret, even with custom automation, I've said this before, I'm probably even on this podcast. I really think standardization is super important. When you're reinventing the wheel every single project, and you're using new devices or new vendors, or you just, there's always that learning curve. Once you can find something that works, stick with it, right? I mean, you should always be exploring the latest technologies and new things, but I see far too many automation companies, usually smaller ones, that are just kind of getting started, and they always say like, well, we got to follow what the customer spec is. I'm like, well, you don't have to. You can push back, right? You can say, all right, customer, you want these very specialized components and a camera that nobody's ever heard of. We can do that, but it's going to cost this. Now, if you use our standards, which will get the job done and it's just good quality and it's about the same price, it's going to be less because our learning curve is less. We know how to use them. We already have software. We've already got the programs written. We don't have to debug it. Various reasons, of course. So yeah, I'm a big believer in standardization as much as possible. And you'd really be surprised how many customers don't push back. When you tell them, yes, your spec is going to cost 1.3x what my solution would be, they're like, yeah, it's fine. Your solution's fine. Just make sure it works.
Absolutely. And then let me ask, on the engineering side, what sort of engineering skills, what sort of engineers do you find maybe excel when it comes to the robotic side? Are there different backgrounds? Are there different sorts of people that you find kind of excel working on robotics or these systems comparative to maybe other sorts of automation and manufacturing solutions?
Yeah, that's a tough question. I find that most of the engineers in automation tend to be pretty well-rounded. For example, some of the best PLC programmers I've ever met, and there have been multiple ones, were mechanical engineers. A lot of times you think of PLC programmers being electrical engineers, and while there certainly are, I'm sure there are a lot that are. I find that for some reason it seems like the mechanical engineers understand the programming aspect better. Not to take anything away from all you PLC programmers who are electrical engineers, of course. But I just, again, I find that in the automation world, people tend to know there might be a mechanical designer or a mechanical engineer, but they know quite a bit about PLCs and quite a bit about electrical, and vice versa too. You've got these electrical guys who, in a pinch, could design a mechanical part and they understand it. So I think automation engineers in general tend to be multifaceted. There's exceptions to every rule. I'm sure, I've known engineers who are, purely just electrical engineers. That's all they do is design panels, and that's all they do. But when push comes to shove, if you ask them mechanical questions, they'd probably be able to answer them as well.
Are you seeing any, I guess, like on that, to continue the conversation on the engineering side, like, are you seeing any shortages of labor when it comes to, I would say, mostly robotics programmers, right? So again, I've worked a lot with, I would say, PLC, HMI, and SCADA developers, but a bit less on the robotics side. So I'm curious what the landscape looks like in 2025.
Sorry, you cut out there just a little bit, Vlad.
Yeah, for robotics.
Yeah.
Like, I'm curious, when it comes to the landscape for robotics programmers, what does it look like in 2025?
Yeah, I think, there's lots of opportunity. Robots are becoming, the price point is coming down. This is nothing new. This has been the story for the last 10, 15 years, but price point is coming down. Ease of use is becoming easier to use. People are putting robots on everything. I got to the point with my company, if it had more than 2 axes of motion, I would throw a scare on it, just because now I've got an infinite amount of motion. I don't have this 2D mechanism that's just going back and forth, and if I need to adjust it, now I'm cracking screws loose, or I'm machining new parts or whatever. No, I'm just changing the points on the robot. So they're becoming almost commoditized to an extent, which means that people are going to be using more of them, which means you're going to need more robot programmers, right? Yeah, I definitely think. It's a good market for robot programmers in general. Sort of specifically, I should say. Overall, automation has had I'd say a rough start to 2025. I think we all thought it was going to maybe be a little bit better than it was. But I'm starting to see the tide is building. I always called it the tsunami of. Yeah, I think anybody who's been in this business knows that there's like no orders, all of the orders. No orders, all of the orders. I'm starting to see that. I think there's a lot of pent up buying that hasn't happened in the last year or so, and it's going to start hitting. I think any time now.
Gotcha. And let me ask you a slightly different question, right? But taking a bit of a step back when it comes to building a robotics company, right? So I certainly talk to a lot of engineers in, I want to say, larger OEMs who have the skill set of, again, programming robotics, programming control systems, who are looking maybe to venture out on their own, right? And of course, Elite Robotics, you guys are much further along, but someone who's just in their maybe early to mid career who knows robotics, what are some of the opportunities for them to maybe look at when it comes to, again, going out as a contractor or maybe starting out a new venture, and
Yeah.
ultimately the challenges in growing that as well, right?
Yeah. Yeah. There's, being a hired gun is always, I'll say the simplest answer, just because you don't have to have, you don't have to have a building. You don't have to have employees. It's just you and your knowledge, right?
Mm-hmm.
I say the simplest. It's not always the easiest, because as anybody knows, when you're a contractor or a consultant, you're always looking for the next job. But if you're good, there are plenty of both manufacturers and, quite honestly, OEMs that could use your talents on a contract, case by case basis. We get calls all the time. People are saying like, "Hey, like we know you didn't build this cell, but we need some help. Can you come out and help us? Our robot lost its program, or the encoder died when it needs to be remastered, or something like that." Those are the types of jobs that certainly a young robot engineer who's got experience could go out and do on their own. You also, the other option always is working for in-house at a manufacturer who has a large number of robots that need to maintain those robots and keep them up and running and all. And then, of course, a traditional integrator as well too. So,
Gotcha. And Sean, you mentioned standardization, which I would assume, I want to say, a younger company or a solo engineer would probably have a very hard time with, right? For the reasons that you've mentioned. So I'm curious, when you talk to customers, how much of your projects are, how would I say it, easy to replicate, right? Let me put a percentage there, right? So that you can apply a current solution to with modified maybe upwards of 30% of it, versus it's a completely bespoke build for their specific application.
That's really going to depend on the company, right? Which and maybe the company is the integrator, right? So we are, I've looked at it a very methodical way of saying, like, I don't want to be doing more than 30 or 40% custom. Custom is very difficult. Even when I was doing assembly work, at R&D, we tried to standardize some platforms, right? So at least we could have some standardized, dial indexing and standardized linear motion machines, so that we weren't reinventing the wheel all the time. We were just working on that, 30, maybe even 40%, maybe of custom. But even within that, you can still customize aspects of the design. Or excuse me, not customize. You can standardize aspects of the design. So maybe you do have it's a custom gripper, but you're still just using the same 3 grippers all the time, a small, a medium, and a large. Yes, the tooling is changing, the spacing is changing, but you're not using XYZ brand gripper instead of ABC. You standardize on a component, and now it takes the decision out of it. I know which one I'm going to use. I'm going to use the small, the medium, or the large.
Mm-hmm. Yeah, and I think it's super interesting, right? Like, again, I 100% agree with you that you should be standardizing as much as possible. And even from the end user standpoint, right? You don't want to have multiple, I want to say, different machines when it comes to maybe your packaging, then your palletizing, that come in with different tools, different software, different controllers. So I think it is a lesson, I would say, for end users as well, right? To try and keep the same, I want to say, standard and reduce the number of
Yeah,
parts that you're using as much as
yeah,
possible.
absolutely,
Um,
absolutely. I mean,
Dave,
I like, I always liken it to, Lego bricks, right? You've got your standard, however many, the 2x6 and the 2x8 and the 2x10s or whatever. You've got those standards, but then there's always the custom ones too. When you buy the Batman or the Star Wars Lego set, they've got that one, those few custom pieces, that they're unique, right? But you still could build most of your model from the standard 100 or whatever it is, standard Lego pieces, and then you've got the other 30% that are customized.
yeah, Dave, what are your thoughts?
Absolutely no. I think that Sean, I think you've talked about standardization in the past. I know that we've talked about it in the past, in every aspect of the automation and manufacturing worlds. And I think most people that have been in an extended period of time all say that the best value for the end user is to go about standardizing. Whether you standardize with a particular integrator on how they do the work, or you have an internal standards document, which is kind of the holy grail that not very many people are actually going to pay to have their standards document upheld. But I think again that is very important. Sean,
Yeah.
I want to go talk about a little bit about maybe similarities and differences of what you've seen now with Elite Robotics, with the material handling work you're doing versus some of those custom applications. And I think you've said that you focus and you try to work on standardizing both of those. So you do as little of additional custom work from one project to the next, which I think makes sense. But I'd imagine there are probably some similarities. I'd imagine there are some differences. I would love to go hear kind of your perspective from 20 years in the very custom side to 6-ish months on the material handling side, and get to hear that from you, please.
Yeah. So I would say you on the assembly side, because there are so many. I think the number of applications are so much different versus on the material handling side. I mean, there's certainly, there's boxes and cases and tubs and all that, but I think there's probably a finite number of shapes that you're going to handle kind of on the back end of the material handling side, because a lot of things end up in a box or in a case or in a tub or in a bucket or tote or whatever. On the assembly side, you're taking all of the pieces of whatever the mechanism or object that is, and putting them all together, and they're all very different and very almost infinite number of possibilities. So I think the opportunity to standardize is much greater on back end material handling, and I think you almost have to, just to be competitive, right? You've got to have a solution that you can say, yep, 80% of that we can do right now. Boom. 20% is the end of arm tool that's a little bit custom, but we're really just taking an old end of arm tool that we've already made and we're just tweaking it a little bit, right? Just to fit your particular product. Whereas, on the front end, it could be, we've got to come up with a completely new way to handle whatever this item is that's never been handled before, right? Or how you feed this item, whether the feeder bowl or vibratory feeders or vision, or how do you feed these things? A lot more varied there. Back end, like I said, a lot of times, it's a conveyor, right? It might be a roller conveyor or it might be a belt conveyor, but it's a conveyor. It's not super complicated, right? Of conveyance.
Absolutely. I think that's good. As a follow-up, you had mentioned some of the applications on the material handling side. And as you first started talking about that, Sean, I'm like, yeah, you probably have lots of robots and robotics currently on the material handling side. And then I was thinking about it a little more, and I'm like, man, there's a lot of opportunity for robotics and conveyance on the material handling side. So as we look into the future, a future which we're almost certainly going to have more robotics, what sort of applications do you think we're going to see? Is it going to be a lot of the I don't want to call them standard, but more kind of straightforward material handling stuff? Do you think it's going to be a lot of the absolute crazy kind of custom things, the last 20%, the last 10% that is the most difficult? Where do you see the robotics kind of area of expertise expanding more in the next 5 years?
Are you asking just on the material handling side or across the board?
Across the board, where do you see it expanding the most?
Yeah, I mean, I see it expanding quite honestly across the board. That's why, I was clarifying. Certainly, they will always, robots are always going to have their place for assembly side, especially when you're talking about, high tolerance. So when you're talking about medical device, when you're talking about things that have to be made correctly, they're always going to have their place, and that's just going to continue to grow. But I definitely do see it on the back end too. So many companies you walk into, people are still picking up, 50-pound boxes and stacking them on 2 pallets, right? And there's no reason that we need to be using humans to be doing that. The technology is there, the reliability is there, the price point is there. There's no reason humans need to be, moving heavy objects around, whether they're doing it with their hands or whether, quite honestly, even whether they're doing it with forklifts. We've all seen the video of multiple videos of the forklift running into the racking system and literally 10 stories worth of stuff falling onto the forklift, right?
Yep.
That's the biggest selling point for the automated storage and retrieval systems, is that won't happen, right? You don't have the guy who isn't paying attention or falls asleep on the forklift and hits something and ruins all your inventory and maybe kills somebody at the same time. So when you start talking about, and that's not technically robotics, but it is. It's servo-driven gantry cranes that go to position. So I mean, depends what your definition of a robot is. I consider that robotics. So yeah, it's back end, definitely. There's tons of opportunity. I remember a long time ago. Gosh, we're probably going like 15 years ago, maybe. Somebody asked Mike Chico, the president of FANUC America. He's like, "All right, so what's your next big market other than industrial robots and what's FANUC going to do next?" And at the time, don't quote me on the exact numbers, but I think he said that the statistic was, of the things that are automatable, only 25% of them have been automated, right? So in the United States, he's like, so our next market is that other 75%. He's like, why would we go into some crazy, and humanoids hadn't even really popped up on the plane, but I could almost, going back, I could get this sense that people were like, oh, are you going to look at, more human-like robots? Or are you going to look at robots that do XYZ or whatever? It's like, no, we're just going to keep making industrial robots, the best ones that we can, and fill that gap. And I mean, to be honest with you, that's what I see here. There's so much opportunity, so many companies that could be automating, and they still aren't. So COVID showed us this, everybody, after the silver lining, after we all figured out that we weren't going to go out of business, because we all thought we were going to go out of business, all of a sudden, boom, the floodgates opened up, and everybody was 2 years plus out, right? So I've always said, if something like that were to happen again, and not necessarily a pandemic, but if the world were to decide we're going to start automating and we got to start onshoring and we got to start taking control of our processes better, if that were to happen again, a couple things would have to happen. One, we'd have to double the amount of integrators we have, because people can't wait 2 years to do this stuff, right? So to get back to a year lead time, you'd have to double those, which just shows that we don't have enough automation companies out there to fill the potential demand if the manufacturers would just decide that they are going to do this.
It must have been a VC question. 75% is simply not enough, Sean. We must grow beyond that.
Exactly.
But speaking of questions, we do have a couple of questions in the chat. So let me bring one of them up. So Jay is asking about the craziest project you have done, Sean, in your career, I'm assuming. and what made it crazy, right? And I'm curious, maybe, do you have a story, like an interesting story, or maybe it's an interesting product, obviously without revealing the end customer or any proprietary
Yeah.
information? Any interesting stories?
I mean, we've done some weird stuff over the years. We did radioactive seeds that are used in prostate cancer surgeries. They basically insert these seeds into, and then basically it radiates you from the inside out, right? And it kills the prostate cancer. But when they're made of various. They don't know how strong they are. Basically, they don't know how much radioactive material are in them. So we had to basically pick these little tiny things up the size of a grain of rice, smaller, pick them up and put them into basically a Geiger counter, measure it, and then sort them by strength into different vials. But the machine had to be, now it's very low level radiation, right? I mean, it's not going to kill you if you want to, but you can't have this, radioactive material just spewing out. So the whole machine had to be lined with lead. It had to have leaded glass. If we ever did break one of these seeds open, though, the machine was going to have to go basically be put into, lack of a better term, quarantine for the next 10 years or something like that. So that one was a little nerve wracking because we actually at one point we had to have live material in the shop. So that was a little odd. I mean, a fun one that was actually I've got. I was just unpacking some stuff the other day. This is a 50 millimeter mortar, so rocket propelled grenade, basically made famous by Terminator 2, I think. Arnold's got this.
Yep. Yeah.
Right? So we did a couple different things on this particular project, but one of them was crimping these two pieces together. So you got your propellant in here, and that's the thing that goes bang. But we had to. A human actually loads us into the machine. The frame was 1.5 inch thick steel. Doors close. It crimps it. And obviously that's because if this thing does go off, we want to make sure that the human's okay, right? So we actually had to build 2 of the frames because they had to go take one out and blow it up on purpose to make sure that it was strong enough. And then once we determined, yep, it's strong enough, we built the next one. So it was interesting. We got to go up to their, to their proving grounds where they blow stuff up, and got to see our frame get blown up.
That's super interesting. I guess I would have imagined that there's very sensitive products that need to be handled by robotics, but it's interesting how you need to be, I guess, a 0% failure rate, right, in both of those scenarios for many reasons. So I would assume there's been extensive testing before you do anything with product, right? So you're just doing dry run after dry run after dry run.
Sure. And stuff like this, we weren't allowed to have live munitions, obviously, at the shop. It was all dummy. But eventually, when you install it, then they're running live product, right? So that's why you want to be.
What's the threshold?
You want to be behind that inch and a half thick steel. You want to make sure that it's
What's the threshold? I guess, are you doing 10,000 runs and everything's good? Hey, we're gonna put live product, or 50 runs. Like, what's the what I mean? Like, how do you even evaluate a scenario like that?
I don't recall exactly what the requirements were, but we had to when it crimped it on there, then they did testing of pull testing and making sure that the crimp was correct and everything. So eventually though, you just gotta put some live product in there. Maybe, I don't know. Maybe they just put a little bit of gunpowder in for the first one, and then a little bit more, and then a little bit. Maybe they work their way up. I don't really recall.
Yeah. No, it's an interesting dilemma. Like, again, because I've done mostly work in food and bev and CPG, right? So we would always have, when you install a new cell, it is almost an understanding that you're going to have spillage, you're wasting a little bit of product, and you're testing and you're making it better. But
you're going to break you're going to break something at some point. Yeah, absolutely. Yeah.
Exactly. But if it's going to blow up your entire cell or put it in quarantine for 1,000 years, then you probably don't want to do it. So it's super interesting.
I was going to say we've got to go blow it up. Definitely feels like an old school episode of Mythbusters. Okay, we have to go get ready now. Everyone moves half a mile back and stands behind this glass, and hopefully we don't have 2-inch thick metal plate flying at us.
No,
sort of situations.
It was actually a little anticlimactic because we were so far away. I mean,
Okay.
we were a good probably at least quarter mile away easily. So yeah, you see the poof, and then you hear the bang, like 3 seconds later.
And you're like, oh, that's it. Hopefully we stayed
Yeah.
together just enough so that we don't have to go redesign the cell.
Exactly.
That's awesome. A couple of notes before questions. We've got John Graham in the comments. John is all about feeders. And then Jay is in the comments talking about how feeders are black voodoo magic. I'm not sure any of us disagree with that.
No, it is 50% science, 50% art. I've always said that, and yeah, that the feeders, sometimes those feed, I'm like, how did you get that to feed? So I give John a lot of credit for that, but don't give him too much credit. I'll get a big head.
Absolutely, we won't. I would say we've also got some comments down here saying that your stories are blowing all of the other stories out of the water, and people are going to have to make up new, better stories in comparison, especially because you just so happen to have that behind you. Now, I don't know if Sean paid Jay any amount of money to come ask that question live, so Sean could roll back behind him and just unbox that. But it is what it is, guys. Conspiracy theories in the comments. We've got another question from Joseph asking if there are any standards in inspection robots in factories. He feels like it's not yet, as there are a bunch of different categories of robots.
Okay.
I think it's a good question. I think there's probably a lot of topics that this could come up with. But Sean, we'll let you go kind of share your thoughts on if there are inspection robot standards. There are robotic standards, right?
Yeah, of course. The robotic standards. I don't know that, I think robotic inspection to me is more of a class of an application than necessarily the robot itself, right? So you can kind of take any robot and by putting a camera or by putting a sensor or whether it be a touch probe or you could for CMM or something like that, right? You could kind of turn any robot into an inspection robot, I think. I don't know of any standards that are out there. As it becomes more commonplace, typically then standards will be introduced. I mean, we didn't have any standards on cobots for the longest time until they finally became popular enough that they determined, all right, we need to have some standards. So I think probably the standards are going to be more on the inspection side, so the tooling or the camera or whatever you're using to measure. That's probably going to be more. You're going to have more of your standards involved with that than you are the actual robot itself.
Absolutely. That is also kind of my thoughts and what I've seen. And I feel like standards are a conversation that could go last like 24 hours long, just on the robotic side. And that is not the conversation / debate that we are wanting to get into at the moment. We do appreciate the question, Joseph. We do appreciate the question. Maybe piggyback off of that. Piggyback off of the fact that for the longest time cobots didn't have standards, and then they did, and now there are some more newer cobot standards from earlier this year. Talking about the next generation of robotics, Sean, I feel like yes, we probably still have most of that 75% of non-automated, non-robotics opportunities still left to go solve now 15 years later. After that quote. But what do you imagine the next generation of robotics is going to look like?
Oh, so in the industrial world, in the manufacturing world, I think they're going to look very similar. They're going to be, 6-axis, 4, 5, 6, 7, 8-axis, robots controlled by servos. I think it's the application software, it's the programming software that's going to change. We're already starting to see more flowchart based programming, drag and drop, ease of use, low code, no code, whatever you want to call that. We're going to see more of that just to make the implementation of the robots easier. Maybe for manufacturers that maybe they don't need an integrator. Maybe if it's easy enough to use, they can buy the robot, buying a standard end of arm tool, in an arm gripper or a vacuum gripper or something like that, do the programming themselves. So I think that's what you're going to see, kind of in the manufacturing side. Outside of manufacturing, we're seeing huge blow up in the construction industry. I just gave a talk up at UF about, they called me up and said, hey, it's the Department of the Construction Management. We're having a seminar and we're looking for speakers about the cities of tomorrow. And I'm like, why are you calling me? And they said, well, we're talking about robots in construction. And we figured that, you would be the one. And I said, so you couldn't find anybody else, huh? So anyway, I gave a talk on, which was kind of cool. Actually, I knew about them, but I did a lot more research too of giving some examples of robots being in construction, doing painting and drywall sanding and truss building and tile laying, and really cool one that basically goes and draws on the floor and shows you where all the 2x4s are supposed to go, where all the piping is supposed to go, and basically you could kind of you take your blueprint and instead of chalk lines, it prints it onto the floor. So those
interesting.
Yeah, really cool little applications like that. I think you're going to start seeing, robots get more into agriculture robots, and then of course we've got the ever-present, humanoid robots, right, which are going to have their place. I think we won't beat this hype horse to death a little bit. I think they are way too hyped, way too much money going into way too few solutions, but there will be winners. There's some pretty amazing things. I think most of us agree that the applications are, it's pretty obvious that they're military applications, search and rescue, hazardous, maybe like after like Fukushima, sending a robot into the plant which has got high radiation and doing search and rescue, or even just inspection, doing visualization or something like that. I think we'll see those. Do I think we're going to see those in the manufacturing floor? I really don't. Not for a long time. So.
It's a really interesting and I guess like polarizing conversation, because it feels like I have friends who are very opposed to humanoids, and then certain people who are very, I want to say, send me a video of a robot, sorting through trash, right? When you have like a recycling center, and you can see that it's going like fairly slow. I'm like, well, you can do that with a Scara robot right now at a much faster speed. And the argument is always, well, you can move that robot somewhere else. I'm like, yeah, sure, but like, how often does that actually happen? Like, when do you have this like multi-purpose solution? So it's an interesting conversation, and I think it's I don't know. I guess it's driven by the fact that at the end of the day, the cost of robotics is dropping.
Yes.
And I think maybe that's why we're seeing some benefits of that ourselves, right? Like as humanoids are receiving more and more funding, we as the industrial space are benefiting from a decrease in cost, which means, normal robotics are being deployed more and more. But it is interesting, right? Like to read about them. I think someone mentioned to me, and I think I mentioned this to you, Sean, off stream. There was some interesting facilities that are doing tests that are more impressive, at least than the videos we get to see. So again, I remain curious, but again, I still remain skeptical of like tangible solutions. Right?
I'm not opposed to them. I think any technology advancement is great. I like to dial back the hype, right? Because especially you get a lot of non-technical people too. They see this and go like, oh my gosh, I'm going to have a robot, doing my dishes in 3 years.
Well, sometimes that's what it takes. Sometimes it takes that kind of hype. You know what I mean?
But I'm like, okay, you just keep thinking that.
Let me ask you, Sean, you did mention, the development of robotics and maybe like the software is changing. I guess, again, like not as intimately involved as you are. So that's why I wanted to, I guess, understand a little bit better what you're seeing, but also how is it tied to the current advancements on the AI side, right? So are you saying that you see a lot more low code, no code solution, or are you seeing, AI being some kind of, I guess, maybe intertwined a little bit with how programming of robotics is being done? Could you elaborate maybe on those tools a little bit more?
Yeah. I think it's a little bit of both. Again, when a lot of people ask, hey, what about AI and robotics? What's the future of that? And I always tell people, well, from a manufacturing standpoint, the whole idea of AI is it's making decisions, right? It's doing intelligent things. It's doing things that you necessarily didn't tell it specifically to do, which in manufacturing, you typically don't want that. You want the exact same thing to happen. You want it to go from here to here, from here to there, every single time. You don't want it making up its own mind that it's going to go this other direction, right? Now, when you're programming maybe that path the first time, I, as a human, can say, I'm going to go in a straight line. But in reality, maybe the fastest path is actually a curve. That's where you can use AI tools to go, hey, what is the optimized path, to maybe put down this silicone, or the optimized location of welding. I saw an application at Automate where they were basically, you would think you're going around a door frame and they were spot welding. You would think, just spot welding around the door frame like this would be the fastest way to do it, working your way around. Well, their software figured out that no, it's actually by doing this, and then turning and doing that, and then coming over here, it was actually faster than doing it linearly. But then now once you use that AI tool, well, now you're done with it, right? Now the robot's just doing what it's being told to do. So I think it's tools. AI is going to be helping us program the robots and maybe come up with, or the PLCs or the controller, whatever it happens to be, better and faster and easier. I told you guys a story not too long ago. I played around just real quick with ChatGPT, just built up a GPT, given a bunch of information, and then just said, hey, write me a Python program that when a box goes to here and it sees a sensor, that it turns this output on. But remember, you may need to have some debounce because it may flip the sensor on and off a little bit. And I just gave it a bunch of words, right? And it generated Python code that was 95% correct, right? And then I said, all right, take that Python code now and convert it into ladder logic. And that was about 80% correct. Which was not bad. I mean, it's a good start, right? And part of it may be just one, I mean, I didn't spend a lot of time on this. You could probably fine tune it to get it better. And two, it's, ladder logic is not the strongest suit for LLMs right now. So, but I think with some work, you could very easily make, a piece of software that takes words, and descriptions, maybe from a mechanical engineer who has no programming background whatsoever, and turn it into, a structured text or a ladder logic, program that is 95% the way there. I think that could be pretty powerful, So if there's anybody out there with a bunch of VC money, they could throw it at us and we'll develop that for them.
And that's an interesting thought, right? I was going to say, Dave, if I may, before I pass it over, it's an interesting thought because I think if you think of it that way, then process engineers are almost going to be the most valuable engineering skill in robotics, right? Because if you understand the process and you can sort of query your way to a good program, that's usually, for an electrical or mechanical engineer, the process and understanding the product is the hardest part of the engineering process. So it's an interesting thought. I guess something to keep in mind for sure.
Yeah.
Absolutely. Let me ask Sean, you talked about some of the advances in robotics, and we talked about like the software advances, and we talked about, I suppose, the concept of the robots maybe becoming slightly more commoditized. Do you imagine the cost for a 6-axis robot is going to come down? Or do you imagine that we've kind of stabilized on what cost is, and we're going to go see advances on software? We're going to go see other kind of value add advances. And if a robot costs 10 today, it's going to cost 10 or 9 or 11 in 5 years. So where do you imagine that pricing is going to look like?
I think it's going to continue to go down just because, well, one, they're going to find ways to make things cheaper. Just the competitive nature of competing robots. Everybody's trying to make things less expensive. You do have a lot of competition coming in from Asia right now. With some really low cost, and they typically tend to be the cobots, but very, very low cost robots. You've got quality issues to work through there, but that still will drive costs down. I do think, yeah, we've probably hit a plateau when it comes to the mechanical side. Servos aren't getting, exponentially better. They're getting marginally better over the years. Gears can only do so much. You can only move metal around so fast. So yeah, I think it's the software that's really going to differentiate, picking vendor A from vendor B when it comes to robotics. So the cost will continue to come down. I don't think it's going to be dramatic, but it will come down. Now, then you come back and again, going back to the humanoid things where they say, we're going to have a humanoid in every house. And they're going to cost $25,000. Well, if a humanoid costs $25,000, then my 6-axis, robot better be, $10,000 because it's a whole lot less complicated than this humanoid. So, who knows? Maybe the humanoid thing is going to help drive the industrial robot prices down as well, too.
Absolutely. I think it'll be interesting. I suppose only time will tell. I will tell everyone what I continue to say every time we bring up humanoids. I don't like robots with faces, and I don't like robots who have heads that don't have faces. So Vlad will certainly be the one of the two of us who's got a humanoid just looming over him during the show, long before I have a humanoid looming over me during the show, or bringing me another coffee or something like that. We've got a couple more comments. We've got a comment here from Graham talking about, Sean, your forays into ChatGPT and having it build ladder logic, saying, interesting concept, using Langrian mechanics to find the most optimized path for speed, for safety, for mechanics, mechanisms, extended life of servo motors and drives for power consumptions, etc.
Yeah, I mean, it can be used for any one of those things, of course, right? I mean, there's been there've been robot manufacturers that have actually kind of had their own form of that. I mean, I think probably one of the most Fanuc had a thing called ZDT, zero downtime, which kind of looked internally at temperatures and speeds and things like that to help optimize and determine, like, hey, that motor, it's probably going to die in the next 6 months, so you might want to replace it so you don't have your downtime, right? That was pre-AI, of course, but I can definitely, I can see using AI to optimize any one of those things, or all of them at the same time, right? Because you really ideally you do want to optimize as many things as possible.
Absolutely. I've done a bit of testing. I am impressed to see what not just even raw ChatGPT is in the process of building, and how close it can get you, as if it's going to replace entire fleets of developers on the robotics side or otherwise. Probably not soon, but as I've told Vlad, I can certainly see and understand why we've got so many of these large FANG companies having huge amounts of layoffs, if these tools can go and deploy half as well as what I'm seeing. And I'm sure their tools are significantly better than the freemium versions of the things I'm hacking around with on the internet. I think Vlad had a question or a comment, and then we've got a question here from John.
A couple of questions for you, Sean. So just to follow up on the innovation, this, I guess, like AI and new ways to optimize things, are you seeing anything on the troubleshooting and maintenance sides, right? So I know, without naming, I guess, the company, there's been innovation, let's call it, on remote monitoring and how you can view the robot through like a camera system. Like, are there other advancements happening, like when it comes to, once the cell's actually put in, how to optimize, maintain, and troubleshoot some of the, I guess, challenges there?
Yeah, there's been a couple startups that I've talked to that are looking at, basically, after you build a machine, feeding it the program, feeding it all the electrical diagrams, feeding it the mechanical assembly drawings. It's more than just that. There's guardrails that we put around it and all that. But the idea being that instead of calling up Elite and saying, hey, this box stopped and it won't go past this sensor and I don't know why, instead of calling us up, now they could go in and say, hey, the box stopped at sensor number 27. Why? And it can say, well, there's a couple different reasons. is sensor 26 blocked? Oh, it is. Well, that's why, because you have to unblock it. Oh, or no, it should be functioning correctly. Go look at the sensor. Is the light on? Is it powered on? Is it actually seeing it? All the way back to, okay, take it back to the cabinet. Is it getting 24 volts? Is it getting a signal? Is the IO? Basically walking the tech through all the steps to debug, not debug, to maintain, I guess, debug. Yeah, it's true. The machine, right? That could be really powerful, I think. And that has capabilities not just beyond automation and packaging machinery. I could see that happening to a lot of consumer products out there too, as well. I mean, how many times have we all Googled some consumer product that you have and you're not sure how to factory reset it and you have to go look up that or how to adjust some setting. It's not intuitive, right? And nobody's going to read the manual. They just want to ask the question. So I could see AI helping that go, well, have you tried this? Have you tried this? Have you tried this? And, because I think everybody's had that experience with the AI is working, you start here and you just kind of, and it slowly funnels you down to your final answer. Unfortunately, sometimes you have to, just the other day, I posted something about it, said, oh, well, yeah, I'll send you those files via Dropbox. And I'm like, oh, great. Here's my Dropbox folder. Here's the link. Yeah, I don't have the ability to upload to a Dropbox. Then why did you suggest it? Why did you tell me to give you a link to Dropbox if you can't upload to Dropbox?
That's super interesting.
I was going to say, I'll make a similar point. I asked if it could go build me a graphic to import into Canva, and it said yes 7 times. And then it kept giving me links that were invalid and SVGs that were invalid. And 3 days later, I'm like, can you do this? And it's like, it gets down to the point, it's like, I'm sorry, we can't do this. And I'm like, but you've been telling me over and over as I was testing, you can do this. So I would agree with that point. There are just some features and functionalities that it feels like it should be able to just binary say yes or no, we can't do this.
Right.
And that is concerning, especially in the world that if you can't go upload it to Dropbox or if you can't go export it into a normal file, like significantly worse things happen. I want to make sure that we ask this question from John. John says, Sean, how do you see the robotics and flex speeding space evolving over the next few years? Are you seeing more demand from customers for flexible solutions that can handle a wider variety of parts, or are traditional feeder systems still dominating most of your applications?
Yeah. It really depends on how many SKUs they want to run, right? And how many different parts they want to run. Do they want a machine that can run 20 different SKUs, but you're only running for half a shift on each SKU, or are you running the exact same part over and over again? And our rule of thumb was, if you're running that one part over and over and over again, we're probably going with a vibratory, hard tool solution that's just going to feed that part, without question, day in and day out, as long as the parts are good and not bent, which we all know that never happens, right? Now, in medical device, a lot of times we would run into this. Well, you've got this medical device that's it uses 1/2-inch tubing, but then we've also got one that uses 3/8 and one that uses 3/4 and one that uses this. So it's very similar parts, but they're different sizes. And then trying to tool a bowl up to be able to feed all of those, while it may be possible, there's downtime to, now you got to take this track off and put a new track on, or adjust these guides or something like that. You got to clean out the bowl. So flex feeding in those cases where you can just dump whatever part that's already been programmed in and say go. Certainly, there's advantages to that too. So I'm seeing. It's really kind of based on SKUs, right? How many SKUs do you really want to run? How flexible do you want this machine to really be? And that's where you have to go back to the customer too and say, okay, I understand you have 100 SKUs, but your volume curve is this huge thing with a really long tail. Do you really want to spend all the money to automate this little tiny long tail, or do you just want to automate this 80-90% of your volume? And do that little long tail, you do it by hand still, maybe, right? Or you have an offline machine or something like that. So that's where you got to go back and really push back on the customer and go, I know what you're asking for, but is that what you really want?
Though that is a very sound question to ask any customer, I feel, in many applications. Sean, let me ask you a fairly different follow up, right? So I would say robots as a service has not been a big topic of conversation, at least in my circles. I want to say over 2025. What's going on there? Are people still, I guess, leasing? Is there still that financial model in place? I know that interest rates have shot up at some point, and now they've
Yep.
stabilized. Are people still using that kind of model to purchase robotics and robotic cells, or not
I
really?
mean, there are companies that are still pushing that model.
Okay.
I can't speak to how successful they are at it.
Mhm.
I well, I hear things. Let's put it that way. I have no
Mhm.
proof of how well they are doing. I don't have hard numbers.
Right.
The hardest thing about that, quite honestly, is getting your money back. Before the life of the machine, right? It's
Mhm.
you can only sell it for so much. You're renting it out. When the customer's done with it, I mean, there could be, yes, there's contracts that's got to be this long or whatever. You might get your money back, but you can never charge enough, I don't think, to make sure that you're going to make really, really good money during that period of time that they're using it. And if it does come
Mhm.
back, basically the machine's worth scrap value at that point. Even I used to say the only way you could do this is if you had a very standard machine that you could really just pick up and move over here and put down. With all you do is just dust it off and you give it to another customer, right? So you can kind of reuse those assets. I got involved with a company that did that, and after really looking at that, I'm still not convinced that even works. Just because
Mhm.
you, as the RAS or mass provider, are responsible for that machine. So if something breaks, if something breaks in that machine, spare parts wise, you're paying for it, right? Because it's not their machine, it's your machine. You're taking care of it. They, if they don't have good operators or technicians, they are going to be calling you every oh, light went off. What's wrong? Like, have you even hit the reset button? No, hit the reset button. Oh yeah, that fixed it. I mean, literally, we got to the point. The joke was like, don't answer them for the first 5 minutes. They'll figure it out. And after 5 minutes, then if they're still calling, yeah, then help them out. But usually, they just honestly, the operators were being lazy. They just weren't even trying. So I think there's a lot of issues on that. It sounds great, and the whole RAS thing kind of took off when it was, basically 0% interest rates for the most part, Now that interest rates have gone up, I don't see that it's nearly as attractive anymore to manufacturers. But like I
Yep.
said, there's still some companies out there that are giving it a shot.
Yeah, it's interesting because I was mainly curious, with the current like tariffs and political
Yeah.
climate, and maybe even with on the reshoring side, if you're trialing something a bit more short term, it would make sense. But yeah, I guess it makes sense what you're saying for
I
sure.
think it makes perfect sense for the customer, right? The customer,
Yes.
that's a no lose for the customer, right?
Mhm.
I just didn't think it made sense for the actual provider. I just don't.
Gotcha.
I don't see how they're making money.
I think the only way that would make sense is if you didn't include the service contracts or there were service contracts up to X%.
Sure.
But again, if you're calling me every 3 hours because a light went off
Yeah.
and you didn't hit the reset and you didn't do all of these other things, the only way to teach a customer that they need to go do some of this understanding themselves is to go charge them money. Without there being a dollar incentive, there's no way. Especially, I mean, outside of a political climate, outside of tariffs, just straight interest rates floating at 6, 7, 8%. There's no way someone could afford to make money as a business and not have an infinite pot of cash, an infinite pot of gold, if you will, going and collecting the interest rates themselves,
Yeah.
and make it to a point where it makes sense for small and medium manufacturers who are the most volatile and risky investments, because all of the large manufacturers are going to go want their capex depreciation when they go buy the robotics. So it's awesome as a concept. I think once you get into it, the sort of people who are going to say, yes, we want to do this, especially at volume, are not the sort of people that you wouldn't want to have owing hundreds of thousands or millions of dollars on your books.
Exactly.
100% agree with what you're saying, Sean. Everyone, thank you so much for joining us. We're going to go ask Sean the last questions that we ask all of our guests. If you have any other questions, please feel free to go drop them in the chat, and we will try to get to them after the show. Sean, I feel like we spent like half of the time talking about what's going to happen in the future, but we're going to go ask you to predict the future again. What do you imagine the next, 5 years of robots looks like in the automation space, in the manufacturing space, or the next 5 years of robotics looks like in general?
Oh, so I know I sound like a broken record, but I really think it is going to be ease of use. And that's a very broad term, but making not just robotics, but all industrial applications easier to use. Right? We've made huge strides with vision system cameras of having really nice GUI interfaces and like, hey, what are you looking for? Draw a box around it. Okay, is this good or is this bad? It guides you through. Versus, I think we all kind of remember the old days of Cognic spreadsheets and very intimidating programming, right?
Yeah.
Even before that, writing in structured text for cameras. Robots now that have drag and drop, flow charting type programming. I've always big proponent. This always ruffles people's feathers a little bit that we need to get rid of ladder logic. Ladder logic is a 65-year-old language that just is there's a simpler way to do it, right? And there's a more powerful way to do it. We need to be looking at those sort of ways so that you don't need a really, really highly trained tech to go in to figure out why a bit's not turning on. I should be able to walk up to it and graphically be able to go like, oh, that's why, because that flow chart is showing me that, that is not turning on. Therefore, this is not turning on. Okay, I see what the problem is now. So I think, ease of use. We don't have to become experts in a new servo motor or a new linear actuator or whatever. If it's just easy to use, most of the time you can load up any kind of cloud-based software nowadays, whether it's payroll or HR or even 3D CAD, or you mentioned Canva, right? I am not a graphic artist at all. I can make some pretty amazing stuff in Canva though, because it guides you and shows you, oh yeah, automatically lines things up and says, hey, this might look better if it was over here and all. That to me, that's ease of use, right? So it made me a better graphic design. Well, it made me not even a better one because I sucked at it to begin with, but it made me a decent, graphic designer just by ease of use. So that's my prediction is we're gonna see more of these software based advances more so than necessarily hardware based advances.
No, fantastic. And I think kind of the follow-up question that we want to ask about career advice probably goes really well into that, right? There are a lot of new technologies coming out, but there's probably a lot of core competencies that people early to mid-career are going to want to make sure to have to go build on these newer pieces of technologies. If someone is early to mid-career, Sean, what is the best piece of career advice you have if they want to get in robotics or if they want to go kind of increase their skill levels to be more useful and maybe have more job certainty in the future?
Yeah, go get your hands dirty. I told engineers that, young engineers from the beginning, go build something, right? Even if it's your spare time, go build a 3D printer, go figure out how to do things on your own that you don't know how to do, right? Go build a GPT, right? Go write your own GPT and figure out some little niche that could fill. Go out and create something. You'll learn so much by failing and making mistakes and figuring out how to do it. It just makes you a better engineer, a better technician. It's never stop learning, right? Just never stop learning. Keep doing it. I do it to this day. I'm always, my wife always yells at me. She's just like, what are you doing now? I'm like, oh, I'm learning Power Automate and of Microsoft's Power Automate to automate MS Teams and whatever. She's like, why? I'm like, because it'll save us time, if we figure out how to do this, She's like, should you go hire an IT professional to do that? I'm like, yeah, probably, but I'm going to do it myself. I'm going to figure it out.
Absolutely. I love that, Sean. Do you have a book or content recommendation, or maybe a project or something else that you can recommend for the audience, please?
Yeah, I usually read a lot of nonfiction. I usually have some sort of really good recommendation on that one. I'm reading a little bit of fun stuff now. There's a gentleman named Alex Roy. The book's called The Driver, but Alex was kind of the modern day Cannonball Run, the godfather of the Cannonball Run. He's the one that broke the record that stood for many years, and he did it by using a lot of technology and things like that. And funny enough, about a year and a half ago, all of a sudden he popped up on LinkedIn, and I've always been a fan of fast cars. So I friended him on LinkedIn, and we started discussing things. And it's really interesting. He's really getting into autonomous driving now. He's doing a lot of investments in the robotics space and all. Okay. So anyway, I've just been chatting with him kind of on and off on LinkedIn about certain things. And then I noticed, a few months ago, I'm like, oh, he wrote this book about his first Cannonball Run experience, right? So I'm part of the way through it now. So it's a little bit of a guilty pleasure, but it's a fun book. But check him out on LinkedIn. I mean, he's a pretty fascinating guy into a lot of interesting things.
Absolutely. We will have to do that. Thank you so much. Not going to go talk about Cannonball Run because that would just destroy the timeline of this show. Having said that, last question for you, Sean, is how can the listeners help? Who should reach out? Are you guys looking for more employees or more customers at Elite Robotics? Your opportunity to go ask the listeners who have come to listen to you anything you'd like.
Sure. Yeah, we are growing. We are looking for people. If you want to relocate down to Sarasota, Florida, definitely look me up. Looking for robot programmers, PLC programmers, mechanical engineers. Pretty much across the board. We're growing. If you've got experience in automated storage and retrieval, definitely give us a call. You can find me on LinkedIn for the most part, or it's Sean at eliterobotics.com.
Awesome. Thank you so much, Sean. I will make a note for all of the folks listening on LinkedIn. Sean and Elite Robotics should both be tagged correctly, so you guys can go ahead and click through from the event for there. Sean, thank you so much for being here. Everyone, thank you so much for joining and all of your questions. Jay, especially for some of those questionable comments that you have in the chat that we won't get into because, again, this is not that sort of show. Having said that, if you have made it this far, make sure that you're following Sean and Elite Robotics as well as Vlad and myself in Manufacturing Hub. If you're watching on YouTube, give us a like, give us a follow and a subscribe. If you're listening in podcast format, please do the like and share and follow and subscribe and rate us 5 stars and all of those awesome things. Until next week, when